Good evening and welcome. However you found your way here tonight, and wherever you happen to be lying as you listen, I am very glad you came. Perhaps you are already in bed, the lamp turned down low, the room gone soft and shadowed around you. Perhaps you're at the end of a long day that asked a great deal of you, or resting somewhere far from your own bed, in the small, quiet hours when nearly everyone else has already fallen asleep. Before we set out, there is one small thing I would love to know. Where in the world are you listening from tonight? If you feel like it, leave a quiet word below to say hello and tell me which corner of the world is holding you as you rest. There is something comforting in imagining so many people, scattered right across the globe, all settling down beneath the same dark sky at the same slow hour. And if these calm recordings help carry you off to sleep at the end of the day, a gentle like and a quiet subscribe help this small channel more than you might guess. Tonight, we are going to travel a very long way from your pillow, out past the warm inner worlds, and across a wide gulf of cold and empty space, to spend some slow, unhurried time with the largest planet of them all. Not a world of legend, though it carries the name of a king of the old gods, but a real place, one you have very likely seen with your own eyes on many an evening without quite knowing what you were looking at. A single steady point of light, calm and bright and unblinking, brighter than any true star in the sky. Tonight we are going to get to know the planet Jupiter. We will drift out to meet it and try gently to take in its size, which is a hard thing to hold in the mind all at once. We will fall slowly down through its clouds and find, to our surprise, that there is no solid ground beneath them at all. We will sit for a while beside a single storm far older than any of us, a storm wider than our whole world that has been turning and turning for as long as people have been watching. We will read the pale cream and the rust-brown stripes that wrap the planet round. We will sink, in our imagination, into the strange deep sea hidden inside it, and stand beneath the brightest curtains of light to be found anywhere among the worlds. And then we will go out to meet its moons, dozens upon dozens of them, and spend some slow time with the four great ones. A world on fire, a world of ice with a hidden ocean, the largest moon in all the sun's family, and an old, quiet, battered one keeping its ancient watch. There is nothing here you need to hold on to. There is nothing to study, nothing to memorize, and there will be no questions waiting at the end. This is not a lesson so much as a long, slow, wandering bedtime visit to another planet, and you are welcome to follow along with as much or as little of it as you like. If you find yourself drifting off somewhere in the middle, long before we make our way home again, please do not feel that you have missed a single thing. Drifting off is exactly what all of this is for, and it would be the loveliest possible way to spend the night. So settle in now, as comfortably as you can. Let the pillow take the whole weight of your head. Let your shoulders come down, away from your ears and soften, and let your eyes close whenever they would like to. Take one slow breath in, and let it ease all the way back out again. And when you are ready, we will drift off, very gently indeed, to go and meet the king of the planets. Let us begin, as people always have, by simply looking up. If you have ever stood outside on a clear evening and noticed one light that seemed steadier and calmer than the rest, one that shone with a plain, silvery, unwavering glow, while the true stars flickered and twinkled around it, then there is a good chance you were looking at Jupiter without knowing it. It is one of the brightest things in the whole night sky, outshone only by the moon and now and then by one other bright planet. It does not blaze or flare. It simply sits there, patient and bright, holding its place among the stars. And people have watched it doing exactly that for as long as there have been people to watch. They did not know what it was, but they gave it the name of the greatest of their gods, the king who ruled over all the others. And looking back, that seems a fitting choice because Jupiter is, by a wide margin, the king of all the planets. To understand why, we have to talk about its size. And its size is the sort of thing that slips through your fingers if you try to grasp it all at once. So let us build it up slowly, one comparison at a time. Start with the world you're lying on. The Earth is not a small planet, as planets go. It is wide enough that it would take you the better part of a day to fly all the way around it in a fast aircraft. Now, Jupiter is about 11 times wider across than the Earth. Set the two of them side by side, and the Earth becomes a small marble, held up next to a great round beach ball. And because Jupiter is so much wider in every direction, all at once, the space inside it grows in a way that is hard to picture. If Jupiter were a hollow shell that you could pour other worlds into, you could fit more than 1,000 Earths inside it, and still have room left to spare. More than 1,000, not lined up in a row, but packed in together, filling the whole round volume of the planet. And it is not only wide, it is heavy, truly and deeply heavy, packed with far more material than any other planet in the Sun's family. Here is the way I like to think of it. Take every other planet that circles our Sun, all of them together, the small rocky ones near the warmth and the great gas giants out in the cold, and imagine gathering all their material into one single pile. Weigh that whole pile. Jupiter, all by itself, is heavier than that, more than twice as heavy as every other planet in the solar system put together. It holds more than 300 times the material of the Earth alone. So when people call it the king, they are not exaggerating for effect. In terms of sheer size and heft, Jupiter simply dwarfs everything else that goes around the Sun. It could swallow all its brothers and sisters whole, and hardly notice they were there. Where does this giant sit? To picture that, imagine the Sun at the center, warm and golden, and the world circling it in their wide, patient rings. Closest in run the small rocky worlds, scorched and quick, and among them the Earth, third from the Sun, turning in its comfortable place. Then there is a gap, and beyond that gap, a broad belt of drifting rubble. And then, well out into the cold, comes Jupiter. It orbits about 5 times farther from the Sun than we do. From out there, the Sun would still be the brightest thing in the sky, but it would look small, a shrunken bright disk, and its warmth would arrive thin and weak, only a small fraction of the light and heat we feel here at home. Jupiter travels along such a wide and distant path that it takes nearly 12 of our years to make a single trip around the Sun. A child born when Jupiter sat in one part of the sky would be nearly grown before the planet returned to that same place. And yet, for all that distance, Jupiter shines in our sky as one of the brightest lights of all, outdone only by the Moon and by one other planet closer in. You might wonder how something so far away, catching so little of the Sun's light, can look so bright to us. Part of the answer is simply its size. Jupiter is so large that even a small share of that thin, far light, falling across its wide, cloudy face, adds up to a great deal, and its pale, high clouds are good at throwing that light back out into space. So the giant hangs there in our evenings, calm and steady and bright, a beacon that has drawn the eye upward for as long as anyone has looked. If you have ever picked out one light that simply refused to twinkle, holding still and clear while the true stars shivered around it, there is every chance you are looking straight at this distant giant without knowing its name. There is one more thing about this giant that is worth resting on before we go any closer, because it seems, at first, to make no sense. For all its size, Jupiter spins remarkably fast. You might expect so huge a thing to turn slowly and grandly, the way a heavy door swings shut. It does the opposite. Jupiter turns right around, one full spin, in only about 10 hours. The Earth, far smaller, takes 24 hours to turn once. But this giant, so much larger, whirls around in less than half that time, so that a single day and night on Jupiter, if you could stand there to feel it, would be over almost before it began. That furious spin actually pulls the whole planet a little out of round, bulging it outward at its middle and flattening it slightly at top and bottom, so that Jupiter is not a perfect ball, but a faintly squashed one, wider around its waist than around its poles. And that same fast spinning, as we will see, is part of what stretches its clouds into the long bands that wrap the planet round, and part of what stirs the deep engine that gives Jupiter its power. It is a giant, but it is not a sleepy one. It is a giant in a hurry. Now let us go closer, and here we come to one of the first strange and lovely truths about Jupiter, a truth that changes the way you have to imagine the whole place. When you picture visiting another planet, you probably picture landing on it. You picture a surface, some ground to stand on, a solid floor beneath your feet, even if that floor is rock or ice or rust-red dust. That is what the inner worlds are like, our own Earth among them. They are balls of rock with a hard skin you could walk across. But Jupiter is nothing like that. Jupiter has no ground at all. There is no surface anywhere on it, no solid floor, no place you could ever stand. It is, from the top of its clouds all the way down, a world made almost entirely of gas and liquid. What is it made of, then, this world without a floor? Mostly the two lightest and simplest ingredients there are. The first is hydrogen, the plainest substance in the whole universe, the same light gas that fills the sun and the stars. The second is helium, the next lightest, the gentle gas that makes a party balloon float up to the ceiling. Nearly the whole of Jupiter, from its cloudy skin down toward its hidden heart, is these two things, hydrogen and helium, with only faint traces of anything else mixed in. In that recipe, it is far more like the sun than it is like the Earth. In fact, Jupiter is made of very nearly the same stuff a small star is made of. It formed from the same great cloud of gas that made the sun, and it gathered up more of that gas than any other planet did. Had it managed to gather far more still, many times more, it might have grown hot and heavy enough at its core to catch light and become a star of its own. It never quite did. It fell short by a long way, and so it remained a planet, the largest of them, a would-be star that never lit. So what would it actually be like to arrive there? Let us imagine falling gently down into Jupiter and see what happens, though I should say plainly that nothing and no one could truly survive this journey. At the very top, you would fall first through a thin, cold, quiet haze, and then into the cloud tops, the highest decks of pale cloud that we see when we look at the planet from afar. Down through those you would sink, and the air, if we can call it air, would slowly grow thicker around you. There would be no moment when you struck a floor. There would only be gas, getting steadily denser and warmer and heavier the deeper you went, pressing in on you from every side with a grip that grew and grew. Down and down you would drift, through layer after layer of cloud, the light failing above you, the pressure climbing, the warmth rising, and still no ground would ever come. That is the strangeness of it. On Jupiter, down is not a direction that ever ends in a landing. It is only a direction in which things slowly get thicker and hotter and more crushing without limit. And somewhere in that long descent, without any sharp line to mark it, a quiet change takes place. The gas around you, squeezed harder and harder by the weight of everything above, stops behaving like a gas at all and begins to behave like a liquid. There is no shoreline down there, no surface where a sky meets a sea, the way our oceans meet our air, with a clean, bright line you could dip your hand across. Instead, the change is gradual and blurred. The thickening gas simply grows so dense, so pressed together, that at some depth it is more like a warm, dark liquid than like any air you have known. If you could keep falling and survive it, you would pass from something like a sky into something like an ocean, without ever crossing a clear border between the two. So when people ask where Jupiter's atmosphere ends and its body begins, the honest answer is that there is no single place. The one shades slowly into the other, gas into liquid, over a great depth, with no floor and no coast anywhere to be found. It is a world you could fall into forever and never once land upon. And it would be a fierce descent, for all its lack of a floor. Up at the cloud tops, where our journey begins, it is bitterly cold, far colder than the coldest winter night on Earth, a place of frozen haze and pale ice crystals drifting in a thin and freezing wind. But as you sink, and the gas thickens and presses in, it grows warmer, degree by degree, until what began as a deadly chill becomes a deadly heat instead. The winds would tear at you the whole way down, streaming past in the great rivers of air we will come to know, and the pressure would climb without pause, squeezing harder with every mile until it grew stronger than anything in the deepest trench of our oceans, and then stronger still. There is no gentle place anywhere in that descent. It is cold, then warm, then hot, then crushing, all the way down into a dark that no light from the distant sun has ever reached. I find there is something quietly humbling in that, and worth carrying gently with you as we go deeper. We are so used to worlds with a top and a bottom, a ground and a sky, a place to stand and a place to fall. Jupiter refuses all of that. It is a planet you cannot walk on, cannot land on, cannot touch in the way you could touch a stone. It is all weather and depth, cloud and sea, going down and down into the dark. And yet, for all that it has no ground, it is very far from empty or featureless. Its cloudy skin is one of the busiest, most restless, most beautifully patterned surfaces anywhere in the reach of the sun. So let us turn our attention there next, to the great storm that has watched over that skin for centuries, and then to the endless bands of cloud that wrap the whole planet round. Of all the features on Jupiter, there is one that people have loved and wondered at more than any other, and it is the first thing most of us ever learn to look for when we point a telescope that way. It is a single great mark on the face of the planet, a broad oval stain set low in the southern half of those banded clouds, glowing in shades of pale orange and deep brick red against the creams and browns around it. We call it the Great Red Spot, and it is not a marking, not a patch of colored ground, not a feature carved into anything. It is a storm, a single storm, one whirling weather system, and it is so large and has lasted so long that it has become the most famous storm anywhere in the solar system. Let us start with how big it is, because that alone is hard to take in. This one storm, this single spinning oval on the face of Jupiter, is wider across than the entire Earth. Think about that for a moment as you lie there. Every storm you have ever known, every hurricane that has ever crossed an ocean on our own world, every great swirl of cloud you have seen in a picture taken from above, could be dropped whole into this one Jovian storm and lost in it like a pebble tossed into a lake. You could take the whole round Earth, with all its continents and seas, and set it down inside the Great Red Spot, and the storm would still wrap around it with room to spare. It has shrunk somewhat over the years we have been watching it, grown a little rounder and a little smaller than it once was, and it is worth being honest that no one is entirely certain why. But even now, shrunken as it is, it remains a storm wide enough to swallow our whole planet. And it turns. Slowly, grandly, it wheels around, the clouds at its edges racing along far faster than any wind that has ever blown on Earth, faster than any hurricane, streaming around the rim of the oval in a great circle. It takes the better part of a week for the storm to complete a single turn. Round and round it goes, a huge, slow, wheeling pinwheel of cloud, lifting warm material up from below at its center and spreading it out toward its edges. Unlike the storms we know, which draw their strength from warm seas and blow themselves out in a matter of days once they leave the water, this storm has no coast to strike and no land to weaken it. It just keeps turning, out on an ocean of cloud that has no shore, with nothing anywhere to make it stop. Which brings us to the most remarkable thing of all about it, more remarkable even than its size. It is old, truly, deeply old, at least as far as we can measure such things. People have been watching this same storm, in the very same place on the planet, for a very long time. Astronomers first began making careful records of a great spot on Jupiter something like 200 years ago, and there are older reports, going back further still, of a large mark seen in that same southern band, though we cannot be quite sure those earlier sightings were of this exact storm. So we cannot give it a precise age, and I will not pretend to, but at the very least, this one storm has been spinning away in the same spot for a couple of centuries. Through all the years that separate us from those first careful watchers, and quite possibly for a good deal longer than that. Every person who has ever looked at Jupiter through a telescope has seen the very same storm, turning in the very same place. Generations of people have been born and lived their whole lives, and grown old and passed away, while this single storm on another world simply carried on turning and turning and turning. There is more to this storm than the wide oval we see from above too, for it is not a thin patch painted on the clouds, but a towering thing with real depth to it. The craft that circles Jupiter now has sounded the storm from above and found that its roots reach far down beneath the cloud tops, plunging for hundreds of miles into the body of the planet, so that the Great Red Spot is less like a puddle and more like a deep, slow, spinning well sunk into the atmosphere. Nor is it entirely alone up there. Elsewhere in the banded clouds, there drift other long-lived storms, smaller but still grand, including a string of pale white ovals that have wheeled along for many years in their own right, and that now and then drift together and merge into larger ones. So the great storm has company of a kind, a scattering of lesser cousins turning across the face of the planet, though none of them has ever come close to matching its size or its long, patient age. Why is it red? Here I must be honest with you, because this is one of those places where our knowing runs thin. We do not fully know. The storm lifts material up from deeper within the planet, and something in that material, worked upon perhaps by the faint light of the distant sun, takes on that ruddy orange color. The exact chemistry of it, which particular substances give the storm its warm brick tone, is still not settled, and thoughtful scientists still weigh one idea against another. So when you picture that great red eye on the face of Jupiter, you can picture it honestly as a genuine open question, a puzzle still being worked at. What we can say for certain is that it is a storm, that it is wider than our world, and that it has been turning for longer than anyone alive can remember. And there is something strangely peaceful, I think, in the thought of it. A storm of terrible winds that has nonetheless become one of the oldest and steadiest sights in all the sky, keeping its slow patient rhythm out there in the cold, while we lie here and rest. Now let us pull back a little from that one great storm and take in the whole face of Jupiter at once, because the storm sits within a larger pattern, and that pattern is one of the most beautiful things about the planet. When you look at Jupiter, even through a modest telescope, the first thing you notice is that it is striped. The whole round face of it is wrapped in long horizontal bands running parallel to one another all the way around the planet, from one side to the other, like ribbons laid round a great ball. Some of the bands are pale, soft creams and whites and gentle yellows. Others are darker, warm tans and rust browns and deeper coppery hues. They alternate, light band and dark band, light and dark, marching in rows from the top of the planet down to the bottom. It is one of the loveliest patterns in the sky, and once you have seen it, you never quite forget it. Those bands are made of clouds, and to understand them, we have to think about what is happening in the air of Jupiter, up and down as well as round and round. The pale bands, the lighter ones, are places where the gas is slowly rising. Warm material lifts up from deeper in the planet, climbs to the cold heights near the top of the atmosphere, and there the substances in it freeze into bright pale clouds, high and fresh and cool. The darker bands are the opposite. They are places where the air is sinking back down, clearing away the high pale clouds and letting us see a little deeper into the planet, down to lower, warmer, browner layers below. So the stripes you see are really a great pattern of rising and falling air, wrapped around and around the fast-spinning planet. The risen air and the sinking air sorted into these neat alternating rows. The pale stripes are the tops of rising towers of cloud. The dark stripes are the troughs where the air slides back down. The clouds themselves, the pale high ones at least, are thought to be made largely of frozen ammonia, a substance that on our own world we know as a sharp-smelling gas, but that in the deep cold of Jupiter's upper air freezes into fine pale crystals, much as water freezes into the ice crystals of our own high clouds. Below those, hidden from our view, there are thought to be other cloud decks made of other substances, layered one beneath another, each freezing out at its own particular depth and temperature. But it is the high ammonia clouds that give the planet its pale, creamy tone, and the deeper layers, glimpsed through the gaps, that lend the darker bands their warmer browns. As for the richest colours, the oranges and rusts and the occasional touch of red, the truth is much the same as it was for the great storm. We are not entirely sure what makes them. Some trace of chemistry, some substance stirred up from below and altered by sunlight, paints those warmer tints across the clouds. But exactly which substance is still an open question that patient people are working to answer. Between the bands, where a pale rising stripe meets a dark sinking one, the air does not simply sit quietly side by side. It races. Along each of those boundaries runs a powerful wind, a great river of air streaming around the whole planet, and neighboring winds blow in opposite directions. One band's air rushing east while the next band's air rushes west. These are like the high fast winds we have on our own world, the ones that carry our weather along and that aircraft ride to hurry across an ocean, except that on Jupiter they are stronger and steadier, and they wrap the entire planet in tidy parallel rows. Where these opposing rivers of air rub past one another, they stir up swirls and eddies and curls, and out of that endless shearing and churning are born the storms of Jupiter. The great red spot is only the largest of them. All across the banded face of the planet, there are lesser storms, smaller ovals, pale spots and dark spots, some white as fresh snow, that drift along within the bands, that spin and merge and slowly fade, that come and go over the years, while the great bands themselves roll on. There is weather down in those clouds of a kind you would find almost familiar too, even lightning. Far below the pale high haze, where it is warmer, there are thought to be deeper clouds made of water, much like our own rain clouds, and within them storms build and flash. The craft that circle Jupiter have caught the glow of lightning flickering on the night side of the planet. Bright pulses lighting up the clouds from within, the same sort of lightning that splits the sky in a summer storm at home, only crackling here in the clouds of a world with no ground beneath it. There is thunder in Jupiter. In other words, though no one is there to hear it, and rain of a sort, though it never reaches any ground. It is a strange thought that so alien a place should have weather we would half recognize, storms and flashes and falling drops playing themselves out in a sky that goes down and down forever. And here is a gentle thing to notice, a difference from home. On the Earth, our weather changes with the seasons, because our world leans on its side as it circles the sun, tipping first one half and then the other toward the light. Jupiter barely leans at all. It sits very nearly upright as it goes around, so it has almost no seasons to speak of, no great yearly swing from summer to winter. What it has instead is a kind of endless, changeless weather, the same broad pattern of bands and storms and streaming winds carrying on year after year, century after century, without any real pause. There is no still season on Jupiter, no calm and quiet winter when the storms lie down. The clouds simply keep streaming, and the storms keep turning, and the great striped face of the planet rolls on, restless and beautiful, and never quite the same twice. Out there in the cold and the dark, we have lingered up in the clouds, in the light, among the storms and the streaming winds. Now let us do the thing we imagined earlier, and sink slowly down into the body of the planet, into the deep and hidden interior, where no light reaches and no eye has ever seen. We cannot go there in truth. No craft we have built could survive the journey, and even our cleverest machines can only listen carefully from above and reason out what must lie beneath. But we have learned a great deal by listening, and the picture we have built up of the inside of Jupiter is one of the strangest and most wonderful things in all of science. So let us go down together in the imagination and see what the giant hides in its heart. Remember that as you descend, the gas around you grows steadily thicker and warmer and heavier, pressed together harder and harder by the weight of everything above. We spoke of how, at some depth, the gas becomes so dense that it behaves more like a liquid than like air. Keep sinking past that, down through a deep, dark, warm ocean of liquid hydrogen, mile after mile, and the pressure keeps on building, greater than anything we could ever make on Earth, greater than the deepest crush at the bottom of our oceans, greater by far. And somewhere very deep down, under that terrible squeezing, the hydrogen does something that hydrogen simply cannot do anywhere on our own world. It changes into a form we almost never see, a form that behaves like a liquid metal. Squeezed hard enough, the plain light gas that fills a balloon is forced into a dark, dense, liquid state that carries electricity through itself, the way the copper in a wire does, or the way a pool of liquid mercury would. Scientists call it liquid metallic hydrogen, and it is thought to make up the great bulk of the deep interior of Jupiter, a hidden metallic sea, immense and dark and hot, wrapped around the very center of the planet. And that hidden metallic sea is not still. Remember how fast Jupiter spins, right around in only about 10 hours. That whole deep ocean of liquid metal is being whirled around by the planet's furious turning, churning and flowing far below the clouds. Now, whenever you have a fluid that carries electricity, and you set it moving and swirling like that, something remarkable happens. It becomes a kind of engine that generates magnetism. This is, in fact, the very same thing that goes on in the molten metal deep inside our own Earth, and it is what gives our world its magnetic field, the invisible force that swings a compass needle north. Jupiter does the same thing, but on a far grander scale, with a far larger and faster and more powerful churning sea of metal inside it. And so Jupiter wraps itself in the strongest magnetic field of any planet in the Sun's whole family, an invisible force reaching far out into space around the planet, so large that if our eyes could somehow see it glowing in the night sky, it would appear larger than the full moon, even across all those miles. The giant is not only huge and fast, it is deeply, powerfully magnetic, sheathed in an unseen field that dwarfs anything the rocky worlds can manage. Somewhere in that deep interior, another quiet and curious thing may be happening, though I should say plainly that it is a leading idea rather than a proven one. Down where the hydrogen turns metallic, the helium mixed in with it may no longer blend smoothly, the way oil will not stay mixed in water. Instead, the helium may gather into fine droplets that slowly sink, falling down through the hydrogen like a slow, strange rain, a rain of helium drifting forever downward through the dark toward the center of the planet. We cannot see this happening, of course, and we cannot be certain of it, but it fits what we can measure. And it is a peculiar and rather lovely picture to hold. A gentle, endless drizzle deep inside the giant, falling through a sea of liquid metal in the pitch dark, where no rain of ours could ever fall. And at the very center, at the heart of it all, what is there? And at the very center, at the heart of it all, what is there? Here we come to one of the newest and most interesting puzzles about Jupiter, And it is a place where I must hedge carefully, because our understanding has been changing in recent years. For a long time, people assumed that deep inside all that gas and liquid there must sit a definite core, a hard, heavy ball of rock and ice and metal, packed down small and tight at the very middle of the planet, with the hydrogen wrapped cleanly around it like the flesh of a fruit around its stone. But a spacecraft that now circles Jupiter, listening closely to the pull of its gravity, has hinted at something stranger. The core, it seems, may not be a neat, hard ball at all. Instead, the heavy material at the center may be blurred and spread out, mixed gradually into the metallic hydrogen around it over a great region, with no sharp edge to it, no clean boundary where core stops and ocean begins. Scientists have taken to calling this a fuzzy core, or a dilute core, a soft and smeared out heart, rather than a firm stone one. I want to be honest that this is a leading idea, drawn from careful measurements, and not a settled fact. Exactly what lies at the center of Jupiter is still being worked out, and the picture may yet change. But if the newer idea is right, then even the very heart of the giant refuses to be simple, dissolving softly into the deep instead of sitting there as a solid stone. Whatever its true shape may be, the heart of Jupiter is a realm of fierce heat and crushing pressure. Down at the core, most scientists believe, it runs hotter even than the glowing face of the sun, pressed beneath a burden heavier than anything we could ever build or endure. And there is one more quiet wonder to carry up with us from those depths. Jupiter sends out more warmth than it ever receives from the far-off sun. Little by little, the planet is drawing inward, sinking under its own vast weight across the long ages, and that patient settling frees warmth from deep within, an old ember left over from the time of its making, still leaking slowly outward into the cold after all these years. So the giant is warm in its heart, in more than one sense, softly giving off its own inner heat into the dark, a faint remembered glow from those distant days when it first drew itself together from the same cloud that built the sun. That deep magnetic engine we have just pictured together does far more than nudge an invisible compass needle. It sets the skies of Jupiter alight. High over the top and the bottom of the planet, wreathed around its north and its south, burn the greatest and most powerful auroras to be found anywhere within the sun's domain. Veils and rings of shining light far brighter and far stronger than the northern lights that shimmer over our own world. If you have ever seen photographs of our own auroras, those green and rose curtains that ripple above the far northern and southern lands on certain clear and frosty nights, then you already hold a small hint of what unfolds at Jupiter, except that there it plays out on a scale that leaves our soft and gentle glow far behind. Let me first explain how lights like these come to be, for it is a lovely piece of understanding and no trouble at all to follow. A world with a strong magnetic field, whether Jupiter or our own Earth, is cloaked in that unseen force, and the lines of that force draw inward toward the two poles, the north and the south, narrowing down toward the planet as they go. Now the space around such a world is not really empty at all. It is thinly scattered with tiny charged flecks, pieces far smaller than a mote of dust, drifting and streaming through the dark. The magnetic field takes hold of these flecks and guides them, sweeping them along its unseen lines and spilling them downward toward the poles. And when those swift flecks come showering down into the high air near a planet's poles, They collide with the gas there and set it aglow, much as the gas within certain lamps shines when a current runs through it. That glow, looped around the pole in vast and shifting curtains, is what we call an aurora. On Earth, it gives us the northern and southern lights. On Jupiter, it gives us something grander by far. And it spins so much faster that the whole system is charged with far more energy, sweeping far more of those tiny specks down toward the poles with far more force. The second reason is stranger and more wonderful, and it ties Jupiter to one of its own moons in a way that has no match anywhere else we know. One of the great moons of Jupiter, the innermost of the four large ones, is a world covered in volcanoes, forever erupting, and it flings a steady stream of material out into the space around Jupiter. That material, caught and charged and swept up by Jupiter's mighty magnetic field, becomes fuel for the lights. So the auroras of Jupiter are fed not only by the distant sun, as ours mostly are, but by the endless eruptions of a nearby moon, pouring its volcanic breath into the planet's magnetic field, to be flung down at last onto the poles as light. That same great magnetic field does something else too, something less lovely but worth knowing. It traps a fierce cloud of charged specks in wide belts girdling the planet, held fast and whipped to tremendous speeds, so that the space around Jupiter, especially close in near the planet and its inner moons, is filled with a punishing storm of radiation. It is one of the harshest places in the whole solar system. Any craft we send to Jupiter must be built almost like a small armored vault, its delicate parts wrapped in heavy shielding, or that radiation would swiftly ruin it. Even so, our machines can only endure so much, and their time close to the giant is measured out carefully against the toll that fierce invisible weather takes on them. The same magnetism that crowns the poles with light also rings the planet with danger. The result is a thing worth picturing as you lie there in the dark. Around each pole of Jupiter, there burns a great glowing ring, a permanent crown of light, far brighter and steadier than the flickering auroras of home. These are not rare and fleeting displays that appear on special nights and fade by morning. They glow more or less always, ringing the poles of the giant in an endless ribbon of light, shifting and pulsing and flaring brighter when the moon's volcanoes are especially busy or the distant sun sends a gust of its own, but never truly going dark. Much of that light glows in colors our own eyes cannot see, in the ultraviolet that lies just beyond the violet edge of the rainbow, so that to a human eye floating above the planet, the display would be quieter than the instruments reveal. But in the fuller view our machines can give us, the poles of Jupiter blaze with the most powerful auroras in the solar system, a crown of light forever burning at the top and the bottom of the largest of the worlds. It is one more way that this giant does everything on a grander scale than the rest, right down to the lights that ring its head. So far, we have kept close to the planet itself, to its clouds and its storms, and is hidden deep. But no visit to Jupiter would be complete without going out to meet its moons. For Jupiter does not travel alone through the dark. It is circled by a whole crowd of companions, a great family of moons, more than any of us could easily name, wheeling around the giant in their many rings and paths. Our own Earth has a single moon, that one pale familiar companion you have known your whole life. Jupiter has dozens upon dozens. The count keeps rising as we look more carefully with better instruments, but it now stands at more than 90 known moons circling the planet, a great swarm of worlds and worldlets orbiting the king. They range greatly in size, this crowd of moons, from the 4 great worlds we are about to meet, each one a proper globe hundreds or thousands of miles across, all the way down to little dark specks barely a mile or 2 wide, no larger than a small hill. And we are still finding them. Every few years, as our telescopes grow sharper and our patience deeper, a few more faint little moons are spotted circling far out from the giant, and the count creeps upward again. It may be that Jupiter has many more small moons still waiting to be found, little dark rocks too dim and too distant to have caught our eye so far. So the true size of the giant's family is not even fully known, and the number we give today is really only the number we have managed to count up to now. Most of these many moons are small, very small indeed, little more than dark lumps of rock and ice, some only a few miles across, tumbling around Jupiter far out from the planet in wide and tilted paths. A great many of them are almost certainly not native to Jupiter at all. They are thought to be wanderers, drifting fragments left over from the making of the solar system, that strayed too near the giant long ago and were caught by its powerful pull, snared into orbit and held there ever since. You can tell these captured ones, in part, by the odd paths they keep, circling far out, tipped at every angle, some of them even going around the planet backward, against the direction the planet spins. They are the giant's gathered strays, a loose and untidy outer crowd of little dark rocks, each one held fast by the same great gravity that rules everything near Jupiter. But in among that crowd of small captured lumps, close into the planet, there move 4 moons that are nothing like the rest. These 4 are large, round, proper worlds in their own right, each one a place with a character and a story all its own, and each one large enough that, if it circled the sun on its own instead of Jupiter, we would happily call it a planet. They are the great moons of Jupiter, and they are so bright and so easy to find once you know to look, that a person with even a small telescope or a very good pair of eyes on a dark night can spot them strung out in a little line beside the planet, like 4 tiny beads on an invisible thread. Their names are Io, Europa, Ganymede, and Callisto, and we are going to spend some slow time with each of them tonight, for they are among the most fascinating places anywhere near the sun. There is a lovely piece of history tied up in these 4, and it is worth telling gently before we go to meet them, one by one. A little over 400 years ago, in the year 1610, one of the first people ever to point one of the newly invented telescopes up at the sky turned that little tube toward Jupiter and saw, beside the bright planet, a few small faint points of light that no one had ever noticed before. At first, he took them for ordinary stars sitting nearby, but he was a careful watcher, and he came back to them night after night, and he saw something that must have set his heart racing. The little points did not stay put. They shifted their places from one night to the next, sometimes on this side of Jupiter, sometimes on that, sometimes hidden behind it altogether. And slowly it dawned on him that these were not stars at all. They were moons, 4 little moons, and they were circling Jupiter, going round and round the giant just as our own moon goes round the earth. It was a quiet moment, one man in a garden with a small telescope, but it changed the way we understood the whole sky, for here was plain proof that not everything in the heavens circles the earth. Some things circle other worlds, those same 4 moons that he watched wheeling around Jupiter all those centuries ago, are the very 4 we are about to visit now. Let us begin with the innermost of the 4, the one that circles nearest to Jupiter, a moon named Io. Of all the worlds we have ever found, near or far, Io is the most volcanic, the most restless, the most furiously alive with eruption. It is a place of endless fire. If the calm, cold, cratered moon you know from our own sky is the very picture of a quiet dead world, then Io is its opposite in almost every way. A world that cannot sit still, forever tearing itself open and spilling its insides out across its own surface. There are hundreds of active volcanoes scattered across it, more than on any other world we know, and at any given moment, a good many of them are erupting. Picture standing there, if you could, on the surface of Io, though it would be a deadly and terrible place to stand. All around you, the ground would be splashed and stained in the strangest colors. Great sweeps of yellow and orange and red and white, as though a painter had emptied every warm color of their palette across the land. Those colors come from sulfur, a substance that on our own world we know as the yellow stuff of certain hot springs, and the source of that sharp rotten egg smell, and Io is drenched in it, coated in bright sulfurous compounds thrown up from below by all those eruptions. Here and there great volcanic vents would be roaring, and from some of them fountains of material would be shooting up off the surface, not in a small spatter, but in immense plumes rising hundreds of miles straight up into the black sky above, so high that they climb clear off the little moon before curving slowly back down. Because Io is small and its pull is gentle, these fountains reach far higher than any eruption ever could on Earth, standing up like great pale umbrellas of falling ash and frost against the stars. And the whole surface is so constantly buried and repaved by all this erupted material that Io has almost no craters at all. On most old quiet worlds, the surface is pocked all over with the round scars of ancient impacts. On Io, any such scar is quickly paved over by fresh eruption, so that the whole face of the moon is forever new. Io wears only the barest wisp of an atmosphere, and even that is strange, a thin and patchy veil of sulphurous gas, breathed out by the volcanoes themselves. When the little moon slips into Jupiter's shadow, and the faint warmth of the far sun is cut off, much of that thin air simply freezes and falls, settling as a pale frost across the ground, only to lift again when the light returns. So Io snows its own atmosphere down onto itself and breathes it back up over and over. Here and there across its surface lie lakes of molten rock, glowing dull red and orange in the dark, their crusts cracking and shifting, and long flows of lava creep across the land from the mouths of the vents. It is, for all its warm color, one of the driest worlds we know, scoured of water long ago by its own endless heat, a place of fire and sulfur and frozen breath, beautiful and terrible and entirely without rest. Now here is the question that matters most, and it has a beautiful answer. Why is little Io so violently alive, when our own larger moon, and most other moons, are cold and dead and still? What keeps its fires burning? The answer lies in that same great gravity of Jupiter that rules everything nearby, working together with the other moons. Io circles very close to the giant, and Jupiter's pull on it is powerful and uneven, tugging harder on the near side of the little moon than on the far side, trying constantly to stretch it. On its own, that might not matter much. But the next moons out, Europa and Ganymede tug on Io too, in a steady repeating rhythm, pulling its path very slightly out of a perfect circle and keeping it that way. And so, as Io goes around Jupiter, the giant's uneven pull is forever squeezing and stretching the little moon, kneading it like a ball of dough worked in a restless hand. First one way and then another, over and over, without pause. All that endless flexing and squeezing rubs the inside of Io and heats it, deeply and powerfully, the way bending a piece of metal back and forth quickly will make it warm in your hands. That heat, generated by the tireless squeezing, is what melts the inside of Io and drives its hundreds of volcanoes. Io burns because Jupiter and the other moons will not let it rest. It is caught in a gravitational tug of war, and the price of that struggle is a whole world set aflame. Let us move outward now, one step, to the next of the great moons, and to a world that could hardly be more different from the one we have just left. If Io is a world of fire, then Europa is a world of ice. It is a moon wrapped from pole to pole in a smooth, bright, frozen shell, one of the smoothest surfaces to be found anywhere in the solar system, gleaming pale and clean against the dark. Where Io is splashed in angry sulphurous color and torn by endless eruption, Europa is quiet and white and strangely serene to look upon, a great pale pearl of a moon circling the giant. And yet, hidden beneath that calm frozen skin, Europa may hold one of the most exciting secrets in all the sun's family, a secret that has made it, in the eyes of many scientists, one of the most important places we could ever choose to go. Look closely at the icy surface of Europa, and you will see that, smooth as it is not blank. It is written all over, with long, dark lines and cracks, thin, reddish-brown streaks running for great distances across the ice, crossing and recrossing one another in a tangle of curves and bands that wrap right around the moon. It looks, in the pictures, a little like the cracked glaze on an old piece of pottery, or like the fractured surface of a frozen pond in the depth of winter, split and refrozen many times over. And there is another curious thing. Europa has hardly any craters. On so cold and ancient a moon, you would expect to find the surface pocked all over with the scars of long ages of impacts, as our own moon is. But Europa's face is smooth and young, almost unmarked. Something has been wiping the surface clean and making it fresh, again and again, erasing the old scars. And the cracks, and the smoothness, and the youth of that icy face, all point toward the same startling idea. The leading idea, and I want to be careful to call it that, an idea, and not yet a proven fact, is that beneath Europa's shell of ice, there lies a hidden ocean. Not a frozen one, but a real ocean of liquid salt water, dark and deep, sealed away under the frozen crust. The reasoning goes like this. Europa, like Io, is squeezed and flexed by the pull of Jupiter and its fellow moons, though more gently than Io is, and that flexing warms its insides. Not enough to set it ablaze as Io is, but perhaps just enough to keep a layer of water down beneath the ice from freezing solid. If that is right, then under a shell of ice some miles thick, there sloshes a global ocean, wrapping right around the moon, and by some estimates that hidden sea may hold more water than all the oceans of the earth put together, perhaps even twice as much. The cracks on the surface would be the marks of that ocean straining against its icy lid, flexing it and splitting it, and letting fresh material well up from below to smooth the old scars away. A whole hidden sea, on a small moon far out in the cold, kept liquid by nothing but the endless squeezing of the giant it circles. And here is why that possibility makes hearts beat faster. And here, above all, is where I must speak carefully and gently, so that hope is never mistaken for fact. On our own world, everywhere we find liquid water, we find life. Life crowds into every damp corner of the earth, into boiling springs and freezing rock and the crushing black of the deep ocean floor, into places with no sunlight at all, where living things feed instead on the warmth and the chemistry welling up from below. And a hidden ocean on Europa, dark and deep, and warmed from within by all that flexing, is not so very unlike some of those deep dark corners of our own seas where life thrives without a single ray of sun. So people have wondered, quietly and carefully, whether that hidden ocean might be a place where some simple form of life could have taken hold. I want to be very clear about this, because it is so easily and so often got wrong. No life has been found on Europa. None. Not a trace, not a sign, not the faintest confirmed whisper of anything living. The hidden ocean itself is not even certain, only a strong and leading idea. And life within it is not a discovery at all. It is a hope and a question and a reason to go and look. It is one of the best places we can think of to search for life beyond the earth, precisely because of that possible sea. But searching for a thing is not the same as finding it. And so, a spacecraft is on its way now, sent across the long dark to swing again and again past Europa in the years to come and study that icy shell and the ocean it may hide, not expecting to find life waiting there, but hoping to learn whether the conditions for it might be. It is a patient, honest kind of hope, and it is enough, all on its own, to make this quiet pale moon one of the most compelling places in the sky. Let us go on outward to the last two of the four great moons, a matched pair in some ways, and yet as unlike one another as could be. The nearer of the two is called Ganymede, and it holds a title worth pausing on. Ganymede is the largest moon in the entire solar system. Not the largest moon of Jupiter, but the largest moon anywhere, around any planet, the biggest of all the many moons we know. It is so large, in fact, that it is bigger than the planet Mercury, the small scorched world that runs closest to the sun. Think of that for a moment. Here is a moon, a mere companion circling another world that is larger than one of the true planets. If Ganymede were not caught in orbit around Jupiter, if it circled the sun on its own, no one would hesitate to call it a planet in its own right. It is a giant among moons, a great round world of rock and ice, and it goes around Jupiter as calmly as if it were nothing remarkable at all. Ganymede has a quiet marvel of its own, hidden and invisible, that sets it apart from every other moon we know. It makes its own magnetic field. We spoke earlier of how Jupiter and the Earth each wrap themselves in an invisible magnetic force generated by moving material deep within. Among all the moons in the solar system, Ganymede is the only one known to do this same thing, to generate a magnetic field of its very own, which means that deep inside it there must be a layer of something molten and moving, stirring away at its core. And like Europa, though more deeply buried, Ganymede too is thought to hide a layer of liquid water somewhere down inside it, tucked away beneath thick shells of ice, another possible hidden sea far out in the cold. Its surface tells a long story if you look at it. Some regions old and dark and battered, others paler and grooved with long parallel furrows, as though the moon had been reshaped in different ages by forces working slowly from within. It is a world with a past, this largest of moons, and much about it we are still working to understand. And then, furthest out of the four, circling widest and slowest around the giant, there is Callisto. And Callisto is the quiet one, the still one, the ancient one. If Io is forever burning, and Europa forever cracking and refreezing, Callisto is a world where almost nothing has happened for a very, very long time. Its surface is among the most heavily cratered of any world we know, pocked and pitted all over with the round scars of impacts beyond counting, layered one upon another, old blows on top of older blows, going back nearly to the beginning of the solar system itself. Because Callisto circles so far out from Jupiter, it is squeezed and flexed far less than the inner moons, so it has no fires like Io's and little of the restless renewing that keeps Europa young. It has simply sat there, out in the cold and the dark, gathering the marks of every stray rock that has struck it across billions of years, and holding them all, unhealed, like an old face lined with the memory of a very long life. In its own faint way, Callisto too may hold some buried layer of water deep down inside, but its face, at least, is as old and quiet and unchanging as any in the sun's whole family. There is a quieter reason that these two outer moons draw the eye of anyone who dreams of people one day travelling all the way out to Jupiter, close in to the giant, around Io and Europa. Space is bathed in that fierce, unseen radiation we spoke of, swept up and flung about by the mighty magnetic field, so strong that it would swiftly harm any traveller who lingered there. But Callisto, far out on the edge of the giant's family, sits well beyond the worst of that danger, in a calmer and gentler place. And so, of all these worlds, it is quiet old Callisto, the ancient cratered one, that people most often picture as a possible foothold in some distant future, a still and steady ground from which to watch the great striped planet turn. It is a nice thought that the oldest and sleepiest of the four might one day prove the most welcoming of all. So the four great moons stand as a kind of set of opposites laid out in a row, from the innermost to the outermost. A world of fire, and then a world of ice and hidden sea, and then the largest moon of all, with its own hidden magnetism, and last of all, a still and ancient world holding the scars of ages. Four companions, four utterly different worlds, all wheeling together around the king. There is one more feature wrapped around Jupiter itself that we have not yet spoken of, and it is a quiet, faint, easily missed thing. Jupiter has rings. When we think of a ringed planet, we nearly always think of another world further out, the one famous for its broad, bright bands of ice. And rightly so, for those are the grandest rings in the solar system by far. But Jupiter, too, is circled by rings of its own, though they are nothing like those bright and glorious bands. Jupiter's rings are thin and dark and faint, made not of bright ice but of fine dark dust, so dim that we did not even know they were there until a spacecraft flew close and caught them backlit by the distant sun. You could look at Jupiter through a fine telescope your whole life and never see them. They are a whisper of a ring system, a few faint dusty bands quietly circling the planet in the plane of its equator. Where does the dust of these rings come from? Here is a lovely small answer. Jupiter has, circling close in near the rings, several of its smaller moons, little dark lumps of rock. And those small moons are forever being struck by tiny specks of debris racing through space, peppered by a fine constant rain of impacts. Each little strike knocks a puff of dust off the surface of the moon, and that dust, freed from the moon, spreads out into a faint band circling the planet. So the rings of Jupiter are, in a sense, made of the slowly chipped away dust of its own small inner moons, a haze of debris knocked loose and strung out into thin dark circles around the giant. They are faint and humble as rings go, but there is something rather lovely in knowing that even the mightiest planet wears a delicate, dusty, near invisible crown around its middle, made from the worn dust of its own little attendant worlds. Now let us pull back one last time and think about Jupiter, not on its own, but as a member of the whole family of worlds, because its size gives it a role in the solar system far beyond its own edges. Jupiter is so heavy that its pull reaches out across immense distances and quietly shapes the paths of countless other things. Out beyond the inner worlds, there drifts a great belt of rocky rubble, and further out still, far in the cold, there are uncounted icy bodies and wandering comets. Jupiter's gravity tugs at all of them. It herds the rubble of that belt, keeping some of it swept into tidy groups and flinging other pieces this way and that. Its pull can seize a passing comet and swing it onto a whole new path, or fling it clear out of the solar system altogether, or, now and then, pull it in to a fiery end. That last possibility leads to an idea you may have heard, and it is one I want to hand to you honestly, with its uncertainty attached, rather than as a tidy fact. People sometimes speak of Jupiter as a great shield or guardian for the inner worlds, including our own. The thinking goes that Jupiter's huge gravity catches many of the comets and stray bodies that come falling in from the outer dark, drawing them onto itself or flinging them away, so that fewer of them ever reach the inner solar system to threaten the Earth. And there is a striking piece of history that seems to fit this picture. A little over 30 years ago, in the year 1994, a comet that had strayed too near Jupiter was torn by the giant's pull into a string of pieces, and those pieces, one after another, came crashing down into Jupiter's clouds, each one blasting a dark scar into the atmosphere wider than the whole Earth, scars that lingered for weeks before slowly fading. It was the first time we had ever watched two worlds collide, and it showed, plainly and dramatically, how the giant can catch and swallow the things that come too close. So the shield idea has a real basis. And yet, I must tell you that scientists genuinely debate it, and it is far from settled. For every comet that Jupiter's pull draws safely in or flings away, its gravity may also, at other times, nudge some distant body out of a quiet path and send it falling inward instead. Whether Jupiter, on the whole, protects the inner worlds or endangers them, or does a little of both, is a real and open question, still argued over. So let us hold it gently, as a genuine uncertainty. The giant certainly shapes the solar system profoundly with its pull. Whether it stands guard over us like a great shield is a claim to weigh carefully, not to swallow whole. It is worth pausing now, near the end of our journey, to marvel a little at how we came to know any of this at all, because for almost the whole of the human story, Jupiter was nothing more than that bright, calm, wandering light we began with. No one knew it was a giant ball of hydrogen without a flaw. No one knew of its hidden metallic sea, or its great red storm, or its family of moons. It was simply the brightest steady light in the sky after the moon, a light that drifted slowly against the stars from month to month, and our distant ancestors, watching it wander, gave it the name of the king of their gods. That was all Jupiter was, for thousands upon thousands of years. The slow work of turning that bright point into a real and detailed world is a story only a few centuries old, and it is worth telling gently. The first great change came, as we heard a little while ago, with the telescope, a little over 400 years ago, when that careful early watcher turned his small new telescope toward Jupiter in the year 1610 and found 4 little moons circling it. He did more than discover 4 new worlds. He gave us the first solid proof that not everything in the heavens goes around the earth, and that was a quiet revolution all on its own. In the years and centuries that followed, as telescopes slowly grew larger and clearer, patient watchers teased out more and more from that bright disk. They saw the banded stripes wrapping the planet round. They found the great red storm and began to keep records of it, watching it turn century after century. They timed the planet's fast spin by following its markings around, and they charted the endless dance of the 4 moons. Slowly, through generations of squinting at that bright, trembling disk, Jupiter firmed up from a mere wandering light into a striped and storm-wrapped world with moons of its own. Those 4 little moons gave us one more gift in those early centuries, a gift you would never expect from 4 faint points of light, for they helped us first measure the very speed of light itself. It happened like this. The moons circled Jupiter like the hands of a great clock, each slipping regularly into the planet's shadow and out again at times you can predict. But a careful watcher long ago noticed something odd. When the Earth and Jupiter were near one another, the little eclipses came a touch early, and when the 2 worlds had drawn far apart, they came a touch late. He reasoned that the light carrying news of each eclipse must take longer to reach us when it had farther to travel, which could only be true if light itself moved at some definite speed, rather than arriving all at once. And so, from the patient timing of Jupiter's moons slipping in and out of shadow, we learned for the first time that light does not cross space in an instant, but takes real time to travel, a truth we drew from watching those same 4 little points of light that a man had found beside the giant not long before. But telescopes on the ground, however fine, could only ever show us the planet from very far away, a small bright disk across a gulf of space. The real knowing of Jupiter, the close and intimate understanding of it, had to wait for our own age, the age when we learned to send machines across that gulf to fly up close and look. And that is exactly what we have done, again and again, over the last half-century or so. The first craft to make the long journey out to Jupiter flew past it about 50 years ago, hurrying by and snatching the first close pictures we had ever seen, proving that a small machine could cross all that distance and survive the trip through the fierce belts of radiation that surround the giant. Then, a few years after that, 2 more craft followed, flying past in turn, and these sent home pictures of a richness no one had been ready for. It was these that first revealed the volcanoes of Io erupting, caught in the act, a discovery that took the breath away. It was these that first spied the faint dark rings, and it was these that showed us close up the swirling detail of the clouds and the great storm, and gave us our first real look at the four great moons as worlds rather than points of light. After those swift flybys came something more patient still. A craft was sent not merely to fly past Jupiter, but to stay, to slow itself and swing into orbit and circle the giant for years, studying it and its moons over and over from every angle. That orbiting craft even dropped a small probe down into Jupiter's clouds, letting it fall on a parachute deep into the atmosphere, sending back its readings as it sank, measuring the winds and the temperature and the makeup of the air until the rising pressure and heat at last silenced it. Our one and only direct plunge into the body of the giant. And in our own time, right now, tonight, there is another craft circling Jupiter still, sweeping around it on a long looping path that carries it again and again over the planet's poles, closer in some ways than anything before it. It is this craft that has been peering down into the deep to puzzle out the fuzzy heart of the planet and gazing at the great glowing crowns of the auroras and listening to the churning of that hidden metallic sea. So even as you lie here in the dark, a small machine of ours is wheeling around that faraway giant, patiently gathering its secrets and sending them home across all those miles, adding, night by night, to the long, slow work of coming to know the king of the planets. And so, very gently, we begin to make our way back. We have travelled a long way tonight, all the way out past the warm inner worlds to the largest planet of them all, and slowly around it and into it and out among its moons. And now it is time to drift home again, back across that wide, cold gulf, back to the quiet, ordinary room where you're resting, back to your own pillow and your own slow breathing. Let us come home softly and take one last calm look at where we have been. We went out to meet a bright, steady light that our distant ancestors named for the king of the gods, and we found, when we drew close, a giant beyond easy imagining, more than 11 times the width of our world, and heavier than all the other planets put together. We found a world with no ground anywhere upon it, a great ball of hydrogen and helium that you could fall into forever and never land, its gas thickening slowly into a hidden metallic sea, its heart perhaps a soft and fuzzy thing rather than a hard stone, hotter down there than the surface of the sun. We sat beside a single storm wider than the earth, turning in the same place for centuries. We read the pale and rust-brown stripes of its endless weather and stood beneath the brightest auroras in all the sun's family. And we went out among its many moons and spent slow time with the four great ones, the burning restlessness of Io, the smooth ice and hopeful hidden ocean of Europa, the sheer size of Ganymede, largest of all the moons, and the ancient quiet of cratered Callisto. We tried all the while to be honest about the edges of what we know. We let the colour of the great storm stay an open question, and the exact heart of the planet stay a leading idea rather than a settled fact. We were careful to call the ocean of Europa an idea, and life within it a hope and not a finding, a reason to go and look rather than something already found. And we held the notion of Jupiter as a great shield gently in the hand, as a real debate rather than a tidy answer. For it is a fine thing, I think, to visit a world and come away knowing not only what we have learned about it, but where our knowing runs out, and to be at peace with both. I hope, more than anything, that it has been a calm and easy journey for you, and that somewhere along the way, perhaps in the slow fall through the clouds, or beside that ancient turning storm, or out in the quiet company of the icy moons, you felt yourself beginning to drift and let yourself go. If you are still awake, that is perfectly all right too. Either way, there is nothing more you need to do now, and nowhere you need to be, and nothing left to hold in your mind. The giant will go on turning out there in the cold and the dark, wrapped in its stripes and its storms, whether or not anyone is watching it, just as it has for billions of years, and just as it will for billions more. So the next time you happen to be outside on a clear evening, and you notice one calm, bright light that shines more steadily than all the twinkling stars around it, you might remember, just for a moment, that it is a whole world, the greatest of them, with its ancient storm and its striped clouds and its family of moons turning slowly out there in the deep. And then you can let the thought go and let your eyes close again and rest. For now, there is only here, and the gentle weight of your own tired body sinking softly into the bed. Let your breathing slow. Let your thoughts grow quiet and dim, and let the memory of that faraway giant carry you the rest of the way into sleep, calm and unhurried and safe. Rest well. The king of the planets will keep its slow and ancient path across the sky while you sleep soundly through the night. Sleep now. All is well, and you are home.